Hello friends, welcome you all in T3P, and today on day 26 we are going to talk about very crucial topic for any organization, or we can say if you are using any cloud, this topic is very crucial for you to understand how we can achieve high availability and fault tolerance in Kubernetes environment with the help of AWS services. See, if you are not aware what exactly means with high availability and fault tolerance, high availability is a stability of a system to keep your application up and running all the time. And when we are talking about fault tolerance, it's a ability of a system. If anything goes wrong, it will up in very less downtime. So this is how we can define these two terms. So when we are talking about the solution, we will talk about these four layers. First layer is infrastructure that will help us to lay down the foundation of our environment. Next, we will talk about Kubernetes and container orchestration. We- it will help us to simplify cluster management. So we will talk about the services here as well, that we will talk about later. Next phase we are having, we will talk about application and services that will help us to ensure application resiliency, how we can achieve high availability and fault tolerance on each layer. The last layer we are going to talk about data management layer that will help us to protect our data. So these are the four layers where we need to think about high availability and fault tolerance on each layer. Then only we can say that our environment is highly available and fault tolerant to any kind of downtime if comes. So when we are talking about the infrastructure layer, we will talk about these services. These services help us to provide high availability at the infrastructure layer, where we are going to talk about Amazon EC2 auto scaling service, Amazon VPC service, Amazon CloudWatch service, Elastic load balancing service. So these are the services which will help us, but how it will help us, that we will discuss one by one. Next phase about Kubernetes and container orchestration layer, where we are going to talk about Amazon EKS service and Amazon ECR service. Along with that, we will talk about Kubernetes network policies as well. Okay. So there is not a specific service in AWS, but we are going to talk about this thing, how it play an important role when we are talking about the high availability and fault tolerance. Next layer for application and services, we are going to talk about many things like stateful sets, HPA, that is horizontal pod autoscaler. We will also talk about self-healing mechanism, and from AWS side, we are going to talk about AWS Lambda service in this phase that will help us to provide high availability and fault tolerance. Next layer we are having data management layer. At this point of time, we are going to talk about multiple services. We are going to talk about EBS and FSX service. From the storage, we are going to talk about Amazon Simple Storage Service, also known as S3 service from AWS. Then we are going to talk about few services related to databases. We are going to talk about Amazon RDS for relational database service, and then we are going to talk about Amazon Dynamo, that is for NoSQL databases. So now our task is to understand how these all services, these all AWS services play an important role to achieve high availability and fault tolerance, right? So let's get started. So now we are going to talk about each services, and also I'll share the link in the description box for a document that you can go through to understand more about this. So let's understand how this Amazon EC2 auto scaling help us. So this service actually help us in providing high availability at the infrastructure level when we are going to talk about virtual machines. So it will help us to automatically adjust the worker node capacity based on workload on our application is, and that also ensure availability even during any worker node fails. So as you know, our Kubernetes environment is like we are having two different types of node. One is control plane, another is worker node where our actual application is running. So this service will help us if anything wrong with this worker node. It will help us to provide auto scaling on that one. If it get failed, it will help us to provide another node for to run our application. Now next service we are having Amazon VPC service. How it help? It help us to isolate your Kubernetes cluster within a private network for the security purpose. Next service we are going to talk about Amazon CloudWatch service. It monitors cluster health and performance for proactive issues identification. So when our application is running, it is also important to monitor our application. If there is any issue related to the performance or any health related issue for our application in terms of infrastructure, it monitors, and once we get the alert, we can take proactive action on that one. Next service we are having elastic load balancing service. This service actually distribute traffic across the cluster that prevent single point of failure. So we are having multiple nodes in a single cluster. So this service help us to distribute traffic to different cluster. So the thing is, if something happen wrong with the one node, it will still work because it is sending traffic to the different nodes. So in this case, this service will help us. So this is how we can use different kind of services at different level to provide high availability and fault tolerance and infrastructure level. Now we will talk about how we can simplify Kubernetes cluster management. So our that can help us to achieve highly high availability and fault tolerance. So first service we are having Amazon EKS service, that you know, it's a managed service that handles cluster operations and integrates with other AWS services. That's why we, for any workload which we are using related to containers and want to manage through the Kubernetes and want to use managed services from the AWS, then we are going to use a major EKS service. Next service we are having a major EC, ECR service, that is Elastic Container Registry service, that stores and manage container images for efficient application deployment. See, we need to deploy this application on some nodes, right? For that one, we need to store these container images somewhere. So we are going to use this Amazon ECR service for this one. Next thing, we also need to understand there is Kubernetes network policies. Okay, so it actually helps to enforce fine-grained network access control for enhanced security. So when we are talking about the high availability and fault tolerance, we always need to think about security as well in the back of our mind. So without security, not a single environment can be highly available because we can get attacked by any hacker or unauthorized person. So for these, to provide these two things, we need to keep in mind security as well. So that's why we need to implement this network policy to enforce fine grained network access control for enhanced security. Now we are going to talk about application and services level layer, how we can provide higher availability and fault tolerance. So for that one, for application perspective, we need to use stateful sets. What exactly it is? It actually manages stateful applications like databases across multiple pods for data persistent and availability. See, our application is associated might be dependent on multiple containers. Okay, so we want that this data should be consistent. So the state of this data, so this stateful set help us to provide this persistency and availability. So that's why at the application layer we will use stateful set, and also we will use horizontal pod auto scaler. So how it will help us? So that it help us to automatically scales application pods based on resource utilization and maintaining performance efficiency. See, the things is right now, for example, our app, our environment is running with 100 containers. If it is needed that we are having more load and we want to make it 150 container, at that point of time this HPA help us to provide auto scaling at horizontal layer. Next thing we need to talk about here, self-healing mechanism. So it will help us to implement liveliness and readiness that proves to automatically restart unhealthy container. If this service is there, how this mechanism works? For example, if there is any pod that is not working well as per expectation that we want from the application point of view, then this service will help us to restart this container, so our application will run without worry. So, as you know, if we face any issue related to the application on our machine, sometimes it gets hung or it is not responding as per our expectation. So, what we do to clear the cache, we just restart that one. So, this self-healing mechanism help us for the same purpose. Next thing, we can use AWS Lambda service, which automates recovery actions, which is triggered by CloudWatch alarms. So whenever any action is triggered by this CloudWatch alarm, AWS Lambda help us to run that particular action whenever it is needed, because it's a serverless service that can help us to provide high availability and fault tolerance. So this is how we can define or we can associate these services at these three layers for high availability and fault tolerance. Now we will talk about the last layer. Let me clear this screen. So now we will talk about data management layer. So in this case, we are having multiple services for different purpose. If we talk about Amazon EVS service or FSX service, it will help us to provide persistent storage for application and also preserve data even if code or node gets failed. For example, our in any case, our container get destroyed or node get failed, at that point of time, these storage help us to provide preserving data. So we will not lose any data in case of any failure. Next service, we are having Amazon S3 service, which will help us to back up our application data and configuration for disaster recovery, or we can say long-term protection. So in so we always keep the backup copy of our application in Amazon S3 service, and also we will keep the configuration if it is needed for any disaster recovery purpose, or we want to keep it for long term protection. Next service we will use Amazon RDS service. It is a kind of a managed relational database service with high availability features like automatic failure and disaster recovery. So whenever we want to use for relational databases, we will use this Amazon RDS service to provide HA and FT at the data management layer. Last service we are having Amazon Dynamo DB service, which is a NoSQL DB service, database service with inherent high availability and fault tolerance due to its distributed architecture. So this is how these services provide high availability and fault tolerance at data management layer. So now we have gone through all layer, how we can use these services and which services help us at which layer. So by strategically integrating these AWS services and following the best practices, we can create high available and fault tolerance Kubernetes environment with the help of AWS services that help us to ensure our application remain resilient and available even if we face any kind of unexpected disruption. So I would like to thank each one of you to join me in today's session. I hope you find something helpful and informative. If you find it, don't forget to click on like button, share with your friends so they can also learn together. Subscribe this channel for more content. And now onwards, we are going to talk about mostly on solution based question or scenario, so that will help us to learn more effectively all together with different kind of services. We will make an ecosystem of all services, how we can use it. So the thing is, I'll also share the link in the description box where whatever I have explained, I have documented there. You can go through that one for easy reference. And also, I'll try my best to mention the services which are related to these AWS services. So you can use the same kind of solution in different cloud providers like Azure, GCP, OCI. I'll try my best to share that in coming days in the same link which I'm sharing in the description box. Just go through that one. Keep learning, keep growing, keep shining. See you in next video.